Bismillahirrahmanirrahim. Assalamu alaikum. Class 10th. I hope you all are safe and sound at your places. Today is our first class of chemistry. I am your teacher, Miss Faiza Kiran. We are starting our chemistry lesson from chapter number 10. The title of the chapter is Chemical Energetics. But first of all, we have to begin our class with quote of the day. This is the saying of Sufyan bin Uyana Rahmatullah alayh. The first step in knowledge is to listen, then to be quiet and attentive, then to preserve it, then to put it into practice, and then to spread it. Wow, what a beautiful saying! My dear students, if you want to seek and share your knowledge in the correct way, you have to follow all these steps. First of all, you have to listen carefully and then you have to stay quiet and attentive while listening. Then you have to preserve it, means you have to recall your learning again and again. Then you have to practice it. Practice means you have to show it in your actions. And finally, the last step is to spread it, means to share it with others. I hope you people will implement these steps in your life. Beta, today's topic is thermochemistry. Thermochemistry is a word which is a combination of two words, thermo and chemistry. You all are very much familiar to the second word, that is chemistry, obviously, but the first word is thermo. Thermo means temperature. So, the study of heat changes in chemical reactions is termed as thermochemistry. Whenever a chemical reaction occurs, the products are produced from the reactants. Here I have mentioned just a verbal journal example. A plus B, two of the reactants are reacting together and they are producing products C and D. So, beta, there are the reactions during which heat energy changes occur. So, these type of heat changes in the chemical reactions are studied in the branch of chemistry that is termed as thermochemistry. How these changes occur? But first of all, we should understand what are thermochemical reactions. Now it is very easy for you. So the chemical reactions which are accompanied by change in heat energy. It means that at the start, when we have reactants, the heat energy is different from the final products, from the heat energy of the final products. You can see here a reaction is occurring which is resulting in the formation of heat. So, whenever the reactants are changes into products, in the system or in the container in which the heat in which the reaction is carried out, there are some heat energy changes. So these type of chemical reactions in which heat energy is occurring, change in heat energy is occurring, are termed as thermochemical reactions. Now thermochemical reactions can be of two types: exothermic reactions and endothermic reactions. Exo means to exit. So whenever the heat energy is released out from the system into the surroundings, these type of reactions are termed as exothermic reaction, due to which the surrounding become hot. On the other hand, endo means taken in. So, the type of thermochemical reactions in which heat energy from the surrounding is taken in or absorbed into the system are called endothermic reactions. As a result of them, our surrounding become cooler or its temperature decreases. Here you can see a pictorial representation. One is the endothermic reaction, in which the arrow indicates that heat energy is transferring from surrounding to the system. As a result, the surroundings get cooler. On the other hand, in case of exothermic reactions, you can see the arrowhead is outside, so the heat energy from the system, from the reaction container, is being released to the surrounding, and due to which our surrounding get warmer. Now we have to see that how we can recognize either a reaction is exothermic or endothermic. So obviously, during a reaction, reactants are converted into products. Whatever the type of reaction it is, we have studied 7 different types of reactions. So whatever it is, whenever the reactants are converted into products, it is called a reaction. And if the heat energy is involved in it, then it is said to be thermochemical reactions. Now, when we need to make a bond during a reactions like addition reaction, two things are combining to make something new, one product. So whenever bond making is required, heat energy is evolved. Whenever during a chemical reaction a bond is formed, it result in the release of heat, and these type of reactions are said to be exothermic reactions. On the other hand, when we need to break a bond, we should provide heat to the system, or the heat energy is absorbed by the reaction. So these type of reactions are called endothermic reactions. What can be the example of endothermic reactions in which we have to provide heat to the reaction? It's combustion reaction. So do remember that exothermic reactions are involved the release of heat and bond making, while endothermic reactions are those in which heat energy is being absorbed and we need to break the bonds in it. Now we have to check for the examples of exothermic reactions. There are so many, but I have listed only three. First one is combustion of coal. Whenever carbon is allowed to burn in the presence of oxygen, it results in the formation of carbon dioxide. And for this reaction, the amount of delta H is minus 393.7 kilojoules per mole. Now here the question arises that what is delta H? So students, do remember that H, capital H, is the symbol of heat, and delta means change in heat. So during the combustion of coal, the change in heat, its value is minus 393.7 kilojoules per mole. Let's check out another example. It is the burning of methane. In the presence of oxygen, when methane gas is allowed to burn, it results in the formation of carbon dioxide and water. And again, change in heat for this reaction is minus 890 kilojoules per mole. Let's see the third example. It is the formation of water. Whenever hydrogen and oxygen are allowed to react together, addition reaction occurs. This is the formation of bond making. So heat energy is released and it is exothermic reaction. Its change in heat value is minus 890 kilojoules per mole. Now let's check out the examples of endothermic reactions. It's opposite of exothermic reaction. The decomposition of water. When water is decomposed into oxygen and hydrogen, then heat energy is to be provided. That is why the sign of delta H here is plus 286 kilojoules per mole. This amount of heat should be provided in order to break down water molecule into oxygen and hydrogen. Have you noticed that the sign of delta H in case of exothermic reaction was negative? While when we are talking about endothermic reactions, the sign of delta H is plus because we provide heat in endothermic reactions. Do memorize it. Another example is the formation of nitric oxide. The combination of nitrogen and oxygen results in the formation of nitric oxide, and it is the reversible reaction. It means that it can go in both forward and reverse direction. Let's check the heat. Change in heat for this reaction is plus 90.25 kilojoules per mole. Now what is heat of reaction or delta H? So thus delta H is termed as heat of reaction. Obviously, whenever we talk about any thermochemical reaction, there must be any change in the heat. That change in heat is called heat content of reaction, and the other name for it is enthalpy. Do remember these two terms are same, heat content of reaction or enthalpy. Heat evolved or absorbed during a thermochemical reaction at constant pressure. There is one condition, that pressure should be constant. So, this is called enthalpy or heat content of reactions. Students, it is represented by delta H. Here is an equation that says that delta H is equal to H2 minus H1. Delta H, we know that it is the change in enthalpy or change in heat content of reaction. It is equal to H2 means heat content of products minus H1 is heat content of reactants. Obviously, whenever we have to find out the difference, we subtract the final reading and the initial reading. So, whenever we subtract heat content of reactants from heat content of product, we get delta H or change in enthalpy. Now let's check them out on the basis of exothermic and endothermic reactions. In exothermic reaction, the enthalpy of product is always less than enthalpy of reactant. Obviously, the system conditions will be changed now. Before and after reaction, the condition of the system in which the reaction is carried out will be changed. So, if in case the enthalpy of product is lesser than the enthalpy of reactants, it means we are talking about exothermic reactions, and the sign of delta H will be negative. In this case, in the case of exothermic reactions, the value of delta H always be represented by a negative sign. Now let's see for endothermic reactions, it will be exactly opposite. Yes, the enthalpy of products is greater than the enthalpy of reactants, because in endothermic reaction heat energy is taken in. So reactants are absorbing the heat energy. That is why the heat of product is greater. And the sign of delta H or will be positive. As I told you earlier in the previous slides, in case of exothermic reactions, the sign of delta H will be negative and enthalpy of product will be less than the enthalpy of reactants. But when we talk about endothermic reactions, then the sign of delta H will be positive and enthalpy of products will be greater than enthalpy of reactants, because in these type of reactions heat energy is being absorbed, while in exothermic reaction heat energy is being released. Here is a point you have to remember, that the accurate values of delta H can be determined by an apparatus or an equipment that is said to be calorimeter. So, delta H or enthalpy or heat content of reaction is measured by calorimeter. One more term we have to understand, heat of neutralization. Before it, you should know what is neutralization. We have studied in grade 9th. Neutralization is an acid-base reaction that results in the formation of salt and water. So what will be the heat of neutralization? Obviously, the heat energy that is released during the reaction of neutralization is called heat of neutralization. But here is something fixed, that is about the amount of water molecule being produced. See the definition. The amount of heat released when 1 mole of water is produced during a neutralization reaction. Obviously, we have to standardize this heat of neutralization. So there is one condition when 1 mole of water is being produced during any neutralization reaction and during which heat energy is released, that is said to be heat of neutralization. Here comes another definition. The amount of heat released when 1 mole of hydrogen ions from an acid react with 1 mole of hydroxyl ions from a base to form 1 mole of water. Same meaning. Obviously, 1 mole of water will be obtained when 1 mole of hydrogen ion and 1 mole of hydroxyl ion react together. We know the chemical formula of water is H2O, so we need 1 mole of hydrogen ion and 1 mole of hydroxyl ion. So, can you tell me neutralization reactions are endothermic or exothermic? Of course, they are exothermic because during neutralization reactions, during the formation of water by the reaction of acid and base, heat energy is being evolved. That's it for today's class. I hope you have understood today's lecture. We will meet in the next class either by physical class or by virtual or online class. Till then, take a very good care of yourself. Allah Hafiz. Take care.